Where's Lovely. So this is a simple script I wrote in Cold Fusion to take a plain text, and let me turn intercept off here for a moment. And it will return to me the ciphertext of whatever I put in. So this is just a very contrived example of an encryption oracle. So here's something interesting. I've changed the end of this, and we immediately see modification in the ciphertext. And if I continue to delete characters here, you can see that this is chopping off more and more of the ciphertext, which means that this is a stream cipher, and also because we can see this changing, but the prefix remains the same, that this is also a stream that this is also using the same key, same IV, and a deterministic cipher. So next thing that we can do is change the beginning here, and we can see that the end doesn't change. So we're not talking about any sort of feedback going on, apparently. So this is interesting. Now, what this actually means, because stream ciphers essentially, once it comes down to it, are just crosswise OR with a nice and complex key generation algorithm. And the only thing separating it from that, in essence, is this feedback. So not having feedback is really bad. So we're going to see why right about now. Now, here's something interesting. So can anybody tell me what what X crosswise OR with null is? X. So if we have a cipher that's essentially crosswise OR, and we put in null as the plain text, what are we going to get as the ciphertext? The key stream. So I'm going to get the first 6 bytes of the key stream here. And I'm going to copy this into burp, which is a lovely tool, and decode this as base 64. So we have the first 6 bytes of the key stream here, which is great. So we're going to stick that into, oh no, I don't want that. All right. Lovely. Okay. So next thing we'll do here, we'll get a ciphertext sample. Oh, what are you doing? So here's the encrypted version of the word DEFCON. So let's copy that, put that into decoder. And now I'm going to do a little bit of XOR here. And we'll just XOR a couple of these bytes together. So hex 42, crosswise OR with hex 26. So we have a D. And then an E. And we can go on and on like this and crosswise OR this key with this key stream with whatever ciphertext we have and decrypt it. So groovy stuff. And because we already have an encryption oracle, that's nice. Now, one funny thing is that if we, like I said, since this comes down to essentially just crosswise OR, if we have plain text and its corresponding ciphertext, we can actually just crosswise OR those two together and get the key stream anyway. So we don't even need an encryption oracle now that we've figured all of this out. So in case the point hasn't been made clear yet, if you're using cold fusion, pick a different algorithm than the default. Right. So, now, let's say that we don't have a shitty cipher. Let's say that we're using something like AES. And let's say we're even using it in a really decent way. So, the thing is, people tend to reuse keys in IVs. So let's say that the only mistake we're making here is to reuse the same key in IV in multiple places. And a lot of people do that because they figure, well, if somebody can break in and figure out the key, then what's the big deal? Like, so what? So what if I'm using the same stuff in different places? The other thing is that if developers don't think that you can mess with input, if they don't think that you can fiddle with it at all, they might not sanitize it. In fact, they probably won't sanitize it. And you would think that if you're using a message authentication code, which I won't go into explaining that, but essentially it provides protection against modification, you would think that this is tamper-proof, that there's no way that this needs to be sanitized, so why bother? Why spend the cycles? So let's say that you have an encrypted password macked in a cookie, like this auth cookie that we're talking about. And that's checked against the database on each request needing authentication. And you find an encryption oracle somewhere else that allows you to encrypt arbitrary data. So you encrypt single quote or 1 equals 1. Let's say it's just the password that's in this cookie, and then plug the resulting value into the cookie. Well, that's ugly. So let's take a look at this in action. So here we have a little login script that takes a username and a password. And this is what it looks like when you log in successfully. So let's take a look at this in the history here. Yeah, this resolution is killing me. So this is ugly because it passes in the URL, and that's terrible, but ignore that. Ignore me. Thank you. So you can see that this sets a username and password cookie. Now, if we stay on this page, if we just go back to it, you'll note two things. That we're still logged in here, but it still shows us the login prompt. Now, something else that's interesting, the username field is populated. And if we look at the response, all we saw was the cookies. Hold on a second. Yeah, so all we see as for the parameters in the request are this encrypted username and password cookie. So this is actually decrypting the cookie and then sticking it in the output. So we've got a decryption oracle here, but it's not what we're talking about right now. Now, let's try some SQL injection here. Let's clear the cookies. And then try admin or double single quote equals double single quote, and we'll put the same thing in the password. So we take a look at the username here and notice that these single quotes are filtered out. They're removed. Now people will generally filter the username but not the password because it's going, if it's going to be hashed and then stuck in a database, then who cares? The thing is though, in this particular scenario, just a spoiler, this password parameter is not being filtered before it gets hashed. So we see that the username and password fields are the same, and in the response we get different ciphertext for the username and the password. So we can say to ourselves, well, maybe this password parameter is not being filtered. So let's copy that and use that as our username cookie as well. If it works, we should have SQL injection. Maybe. So we go back to the index, and let's turn intercept on and burp so I can actually catch this as it goes. So we'll grab the password cookie, which contains our SQL injection string encrypted, and stick that into the username parameter. Hit forward. Oh, that's ugly. Well, that's what I get for doing a live demo, I guess. Let's try this again. Yeah, that's ugly. All right, well, I'm not going to waste any more time on this live demo. It works. So, so we get logged in, and it bypasses the SQL injection checks where we would not have been able to by simply putting the strings directly into the username or password field. So, groovy stuff. I'm sorry it didn't work. So let me just log in with the valid credentials, and I'll show you the next portion. So we have a couple different URLs here that we now have access to, and if we take a look at the input here, we have some sort of ciphertext being passed to a file parameter in getfiles.cfm, and I wish the resolution was a bit bigger because it would be easy to see that the beginning of the ciphertext. So here we see 9/F, 9/F. So these ciphertexts are starting with the same thing. Now, I wonder what would happen if we were to plug that data in here. So we get an error which decrypts that ciphertext for us. So we have another decryption oracle here. We also can encrypt arbitrary data. So we can just stick anything into the password field and then grab the cookie and put it somewhere else. So let's do that. So what I'm going to do is to access a file in this test bed called secretdata.txt, which is in the root. And so I'm going to put a whole bunch of / secretdata.txt, and then we'll have this attack string as our password cookie. All right, everybody think good thoughts. Well, that's ugly as well. But you can see what I was trying to do here. Apparently, I needed more .. slashes. But you can see that it's, you can see how this was working, and you would have seen my secret love for Moxie Marlin Spike. Also, lulsec APT return on investment. Exactly. I encrypt whatever password I like, and in the cookie, I get the ciphertext for it. Yeah.